Assalamualaikum and a very good morning to the examiners. My name is Najwa Mashitah and I would like to present to you about my study. The title of my study is Food Preferences and Reproductive Ecology by rhinolophus stheno in Kra Wildlife Reserve, Pahang, Malaysia. For your information, bats comprise around 50% of the mammal species in tropical forests, and approximately about 20% of the mammal species are from worldwide. It is based on Lim et al. 2006. Bats live almost everywhere, like in the rainforest, mountain, farmland, woods, and city in all over the world, except at the Arctic and Antarctic, due to the low temperature of the surrounding that may inhibit the rate of emergence of the insect. Bats are mammals and they uh, give birth to their young and take care of their young. Bats are classified in order Chiroptera, which means handy wing. Their suborder are Yangichiroptera and Yingterochiroptera. Bats are the only mammals that can fly because they have a wing structure that are being modified from their falling, with their membrane structure um, is being stretched between the elongated finger bone, and they have a powerful chest muscle to flap their wing. The study species of my in my study is rhinolophus stheno. Rhinolophus stheno is an insectivorous bat where they roost in the cave. Rhinolophus stheno is a medium-sized horseshoe bat and cover most of muzzles and have a distinct supplementary noseleaf with three grooves of lower lips, with the morphological characteristic include they have a dark brown to reddish brown or orange color, and they also have a dark brown wings. Then Robinson 1996 has stated that the frequency of echolocation score is approximately at 85 to 90 kHz, while Kingston 2000 has stated that the echolocation call is at 86.1 kHz, with its forearms at 48.8 mm both in Malaysia. But according to the Soba et al. 2003, the length of the forearm approximately in the range of 41 to 47.5 mm. The populations of rhinolophus stheno is stable with least constant of IUCN global status. The locations of my study site is at Kuala Lompat Research Station, Kra Wildlife Reserve, Pahang, Malaysia. For your information, I do not do sampling at this location, but I do obtain the fecal sample from Kra Wildlife Reserve, Pahang, Malaysia. The objective of my study is I want to determine the main insect order consumed by rhinolophus stheno, and I also want to know whether there is a significant differences of insect order consumed between different reproductive stages like in lactating, pregnant and post-lactating of rhinolophus stheno. The methodology in my study, as I said before, I do not do the sampling at the crowd, but I do the field work and get the experience from the study of the master student of Dr. Ain at Youth Park Munggit 1 and Munggit 2. Okay, at the location, we will set the hub track at respective point, and at the respective hour, we will go there and collect the bat, okay, that are being trapped in the hub trap. So then we will collect them and put them into the cloth bag, and then we'll go to the camping site, and then we will start the identifying process where we can distinguish or differentiated their species by measuring their forearm length, their hind foot, their tail, and we can know their reproductive status, and we also can differentiate their gender by looking at their nipple and so on and so forth. For the lab work, we do fecal sample analysis where we get the fecal sample from the crowd in the appendix tube. Then we put it out and put it on the petri dish. Underneath the petri dish, there is a grid there being glued below the petri dish. Then we moisten the fecal sample 1 day. After that, we will drop 1 to 2 liters of alcohol for us to easily separate the insect fragments from the fecal sample. Then after we separate the insect fragment, we do photo reference. Okay, we refer the insect fragment, okay, with the photo reference of insect, so we can know which order they may include with. So then we separate them into different order in respective grid, so that it will make us to easily calculate the percentage volume of insect odor and also the percentage frequency of insect odor. Next, we do a statistical analysis because we want to know the significant difference. Okay, first we do fragment test SPSS version 24 and Wilcoxon sign rank test. For the result 1, for my first objective, I can say that the main insect odor consumed by rhinolophus stheno is Calypteran, which is 60%, followed by the 10% of other unidentified odor, 8% of Diptera, 6% of Hymenoptera, followed by the 5% of Hemiptera, and both 2% of Lepidoptera and also Isoptera. For the result for my second objective, in fragment test, there was a significant relationship between volume of insect consumed and insect odors, because the p-value is less than 0.005. Then in Wilcoxon sign rank test, there was a significant difference between volume of insect consumed and reproductive stages, and also between the volume of insect consumed and insect odors, and between the insect odors and reproductive stages. Based on this bar graph, we can see the correlation between the percentage volume of insect odor, type of insect odor with different reproductive stage, where PL indicate the post-lactating, P indicate the pregnant stage, and L indicate the lactating stage. From this result, we can see that pregnant, lactating, and post-lactating, for pregnant and lactating, they consume a variety of insect odor. So we can see the percentage of Calyptera, Diptera, Lepidoptera, Hemiptera, and so on and so forth is much more varied compared to the post-lactating, where the Hymenoptera is 0%, where the Hemiptera is 0%. It shows that in post-lactating stage, the insect consumed is less varied compared to the pregnant and lactating. This show a great significant difference in their relationship. Okay, what I want to tell is, for post-lactating, the sample of the insect is much more little or less compared to the pregnant and lactating. That's why it inhibits such this result. Okay. For the discussion, for my first objective, I can see that the result of this study, they have discovered that insectivorous bat, they feed on the 5 insect order, like Calyptera, Hymenoptera, Hemiptera, Lepidoptera, and Diptera. So for my first objective, I can say that the main insect consumed is Calyptera. Okay. Rhinolophus stheno, they feed exclusively on Calypteran. Hard body fragments such as elytra of other Calypterans were the most frequently encountered food item and ranked first in the average percentage frequency at 67%. Okay, so for my second objective, um, the result has stated that the order consumed by the rhinolophus stheno is much more varied in lactating and pregnant. Okay, we have like 5 to 6 insect consumed, but in post-lactating and non-reproductive, the insect order consumed is much more lesser compared to the pregnant and lactating. We can see here that pregnant and lactating are opportunistic, where they feed on much more variety of insect order because they want to compensate the energy demand or in during the pregnant and lactating stage, because they use a lot of energy to compensate to because pregnant use a lot of energy. Okay. In addition, as we say that in first objective, that Calypteran is the most consumed insect order because they are the largest insect group, where they are approximately about 300 to 400,000 beetle species has been recorded, followed by the Lepidopteran. Um, and it is being recorded by Royal Entomology Society 2019. Okay. From the insect references, some of the order are commonly present in the fecal samples of my targeted species. The abundance of identified insect order may be one of the indicators why they are commonly found in the diet of insectivorous bat. Okay, uh, for your information, there is a little known about the feeding preferences of rhinolophus stheno. So I am comparing with the diet of Hippocedarus alter from previous study, because they have stated that the consumption of Lepidopteran were the highest during lactating period because it complement with the high occurrence of moth populations and the monsoon of the study area, while Rhinolophus stheno prefer Calypterans rather than Lepidopterans. Okay, but they still small percentage of lepidopteran consumed by rhinolophus stheno. So here I can see that maybe a rhinolophus stheno consume a beetle because at that time maybe it complement with the high occurrence of beetle population, okay, at the study area. In conclusion, I can conclude that the major insect order consumed by Rhinolophus stheno, regardless different reproductive stages, are Coleoptera. Okay, but they have a significant differences between the diet of Rhinolophus stheno in different reproductive stages, where non-reproductive and post-lactating female they consume less variety of insect compared to the pregnant and lactating female, because the pregnant one need more energy because they have offspring inside of their stomach. Okay, and the lactating female they have to give energy, the milk, to the young, so they need a lot of energy, so they are opportunistic feeders where uh, they feed a lot of variety of insect order. Okay, in future I am recommended to the future researcher to include a large fecal sample in order to have an precise study about the food habits of Rhinolophus stheno. Thank you. What are the advantages of knowing the bat echolocation frequency? There is a device to measure and record the echolocation call frequency, and we can translate it, the echolocation call frequency, to human range hearing frequency. So we can discover new species, we can differentiate one species from another, and then we can have a proper study of the species of bat that we want to focus on. Besides being the most abundant insect at your sampling site, what makes the Calypterans being the most preferable diet to the insectivorous bat? Okay, Calypteran is a big size and they contain some of nutrient that will complement with the nutrient need and energy demand of the bats. If Calypterans were taken off from the ecosystem, will the insectivorous bat still survive? Calypterans can able to survive because they have a variety of order to replace the loss of Calypterans like Orthoptera, we have Diptera, we have Lepidoptera, and many more. Besides that, they also have a rapid life cycle, reproductive cycle. So they can reproduce rapidly, so they can compensate the loss of collaterals order. What will happen to the insectivorous bat if A. Released in busy city at daylight? For your information, bats will avoid natural and artificial light, so they will find a way back to forest or find any dark place like abandoned building to roost into the abandoned building. So B. Release in EMCO city with abundance of colored terrain. First, if the EMCO city is totally collapsed, so the light is really little, so they may feed on the colored terrains. But if the light is everywhere, still functioning, even though EMCO, so they will go to find abandoned building or some dark places. Thank you.